Okay, so this one is 3 times 3 times 3 times 3 times 3, which it repeated for 1, 2, 3, 4, 5. So we're going to write it as 3 to the power of 5. That means 3 repeated itself for 5 times. Okay, now this one, 7 to the power of 5 times 7 to the power of 9 divided by 7 to the power of 6. We have our rules of if it is like something to the power of 5 times something to the power of 9. This one, we have to combine it as, again, the same base, but then the power is going to be 5 plus 9. So this one, we're going to, in the first place, we're going to have, leave the 7 to the power of 6 at the bottom, but we will have 7 to the power of 5 plus 9 on the top first. Okay? And then we're going to have, simplify that, we're going to have 7 to the power of 14 over 7 to the power of 6. Now, this is the first rule, right? We have a second rule that it's when we're trying to divide, okay? Let's say this is 14, right? Divided by the same base of the 6, okay? Which is equals to what we've seen just now is 14 over smiley face to the power of 6, which is equals to the smiley face, same base, but then it becomes a subtraction at the exponent, 14 minus 6 on the top. So this one, you're going to have 7 to the power of 14 minus 6. And that's equal to 7 to the power of 8. That's the answer. Okay. Now, same rule here. We have, they are the same base, 2 and 2. They're multiplied between the 2's, but then to the top is a 3 and to the top is a 6. So we apply the rules, which is the a to the power of b times a to the power of c is equals to a to the power of b plus c. The b plus c happens at the exponent side. So we're going to write it as 2 to the power of 3 plus 6. That's equals to 2 to the power of 9. Okay, part B, again, the rules, I'll write it in green. A to the power of b divided by a to the power of c. We're going to have a to the power of b minus c. Okay, outside is the divide. It will turn to minus in the exponent part. We're going to have 3 to the power of 9 minus 4, which is 3 to the power of 5. Okay, now part C there. Now, part C, you could have completed at the bottom for this fraction first because, or you can just multiply to the other side. It's up to you. So, within this part, you can then write it as 5 to the power of 4 plus 6, which is 5 to the power of 10. So, in the first step, you can then write it as 5 to the power of n divided by 5 to the power of 10, and that's equals to 5 to the power of 3. Okay, so now you can do two things. One, it's you can stay here and then use the a to the power of b minus divided by a to the power of c, so which is 5 to the power of n minus 10. Okay, because that's a division as a whole, which is a to the power of b divided by a to the power of c, which is a to the power of b minus c on the top. Okay, and that's equals to 5 to the power of 3. Now, since it is 5 to the power of something equals to 5 to the power of something, we could have extracted this n minus 10 equals to 3, which is n minus 10 equals to 3. You don't have to write the 5 anymore. So the n equals to 13. Move on. Again, this one, it's pretty straightforward. 2, which is a to the power of b times a to the power of c, which is a to the power of b plus c. So we have 2 of 3 plus 4 on the top, which is 2 to the power of 7. Okay? Now, find the value of n. 280 equals to 2 to the power of n times 5 times 7. The first thing we can do is to divide it by 5, right? So that we can cancel out the 5 on the right hand side. So 280 divided by 5, we're gonna have 56. So which is 56 equals to 2 to the power of n times 7. The next thing we can do is to divide 7 on both sides, right? Because we can cancel out the 7 on the right hand side, which is 8 equals to 2 to the power of n. Now 2 to the power of n equals to 8. The next step you need to think is, this 8 is equivalent to 2 to the power of what, right? So you can then count because it is a small enough number. So 2 to the power of 1 is a 2, 2 to the power of 2 is a 4, 2 to the power of 3 is an 8. So we can then replace this 8 with 2 to the power of 3 equals to 2 to the power of n. And again, because they have the same base, you could have extracted the exponent, which is 3 equals to n. That's it. Number 4, leave your answer in index form. Again, this one, is a pretty basic one, which is a to the power of b times a to the power of c equals to a to the power of b plus c at the exponent, which is 7 to the power of 5 plus 3. That's equals to 7 to the power of 8. Division, which is a to the power of b divided by a to the power of c, which is a to the power of b minus c at the exponent. Your answer will be 5 to the power of 9 minus 3, which is 5 to the power of 6. So this one's a little bit tricky, but everything it's with the 2's, right? So this 2 to the power of 9 times 2 to the power of 4, it's on the top of the fraction line. So we could have combined it first because there's no unknowns there. So we can then use the a to the power of b times a to the power of c, a to the power of b plus c, this formula. So we will have 2 to the power of 9 plus 4. Okay? So we then gonna have 2 to the power of 13 divided by 2 to the power of n equals to 2 to the power of 8. So now on the left hand side, you could have used a to the power of b divided by a to the power of c, which is a to the power of b minus c. You will have 2 to the power of 13 minus n. Right hand side it's 2 to the power of 8. Now, because your unknown is the 13 minus n, right? So this will equal to this, as they have the same base at the bottom. Nothing changed. So you're going to have 13 minus n equals to 8. So negative n equals to 8 minus 13. Negative n equals to negative 5. N will equals to 5 because both sides times minus 1. Move on. Now this one, you see that it's 6 to the power of 5 times 6 to the power of 2 times 6. Now this 6, don't think that there's no exponent on the top and you just leave it like nothing. Remember, 6 exists itself, it shall be to the power of 1. That's a hidden one, which they didn't show. You can use the formula that we given to you, a to the power of b times a to the power of c. Now you could have making this a to the power of d, which is all added on the top, b plus c plus d. So this time you will have 6 to the power of 5 plus 2 plus, don't forget the 1, okay? Don't forget that it's not a 0. So it will be 6 to the power of 8. Now we have a new thing here. This one is we call it power of the power, which is a to the power of b. Outside we have the c, right? We will then apply the formula of a to the power of b times the c. Okay, because this is the power. This 2 squared is applied to the entire thing. So we will have 9 to the power of, we will have 9 to the power of 7 times 2, which is 9 to the power of 14. Another way you can think of that, it is square, right? So which is 9 to the power of 7 times 9 to the power of 7, which is 9 to the power of 7 plus 7. That's also equals to 9 to the power of 14. Same thing. Okay. So now for this one, let me use another method this time. So we would like to isolate for the n number. So first of all, we could have done it in a way that we multiply both sides by 5 to the power of 6. 5 to the power of 6. So we will have 5 to the power of n times 5 to the power of 3 equals to 5 to the power of 4 times 5 to the power of 6. So you could combine the right hand side as 5 to the power of 4 plus 6 first, which is 5 to the power of 10. And then the left hand side remain as 5 to the power of n times 5 to the power of 3. Now you can divide both sides by 5 to the power of 3. So you're going to have 5 to the power of n equals to 5 to the power of 10 minus the 3. Because we have the formula for a to the power of b divided by a to the power of c as a to the power of b minus c. So you will have 5 to the power of n equals to 5 to the power of 7. Because they have the same base, the exponent will be the same. So n equals to 7. Next, again, same formula. This one is pretty straightforward. So which is 2 to the power of 4 plus 3. The multiplier at the bottom will turn into the plus on the exponent part, which is 2 to the power of 7. This is 3 to the power of 8 and then minus the 2, which is a to the power of b divided by a to the power of c turns into a to the power of b minus c. That's equals to 3 to the power of 6. Okay. Now this one is another new thing, which is 5 to the power of something equals to the bottom as a complete 1. So we will have a thing called anything to the power of 0 that's equals to 1. So that means the only thing that we can make it equals to 1 as the whole thing, it's when the exponent is a 0. So we will be writing it as, okay, 5 to the power of x is a 1. And because we know that this is 5 to the power of x and also equals to anything to the power of 0, so we make it 5 to the power of 0. So we can then see that, okay, x is equivalent to the 0. So x equals to 0. Okay, now we have the negative exponent. Now, be careful. Negative exponent means you have to take the reciprocal. Okay, we have to take the reciprocal. All right. So by taking the reciprocal, we're going to have something like this, which is equals to 1 over 2 to the power of 3. Okay. Next. This one, it's 1/3, right? If the power or if the exponent, is 1 over something, it means you have to take the xth root. So essentially, for example, anything to the power of 1 over 2 means you have to take the square root. Anything to the power of 1 over 3, it means you have to take the cube root, so on and so forth. Okay? So this one, that means we have to take the cube root of everything. So that's equals to the cube root of the entire 27 over 343. Which means that we have to take the cube root of the 27 divided by the cube root of the 343. Okay? We take the cube root of the top, we're gonna have a 3 because 3 cube is a 27, and then the bottom, take the cube root of 343, we will have a 7. So that's going to be 3 over 7 at the end. Okay. So now this one's a little bit difficult or different because we have a square root and outside we have a power. So we can then change the middle one from the square root as 3 over 8. Remember, we use a bracket. This square root, we will turn it into the 1 over 2. Okay, let me highlight it. This square root, it means this 1 over 2. And then the outside, the original bracket with the 4. Now we can then use what we have learned from the power of the power, which is a to the power of b outside there's a c, which is a to the power of b times c. So we can then multiply these two together. That's equals to 3 over 8 to the power of 1 over 2 times the 4, which is 3 over 8 to the power of 2. Now the 2 has to be applied into each of them, so 3 squared over 8 squared after we break the bracket, because the 2 has to go to the top and the bottom as well. We will have 9 over 64. Move on. Again, this one, it's power of the power. So we will have 9 to the power of, we'll have a to the power of b to the power of c as a to the power of b times c. So you see the power of the power, we multiply the power together. 9 to the power of half times the 4. Operated on the exponent part, that will be 9 to the power of 2, because 1 half times 4 is a 2. 9 squared is 81. That's it. Okay, express that as a power of 25. That means they want to see the 25 as a base, and then the exponent is another number. So how can we break it up? We know that 25, it's gonna be 5 squared, right? So let's just try to break down the top 20 into two parts that contains the 2. So that it's a reverse process of the power of the power. So if we break it down the 20 into 2 times 10, then we're gonna have 5 to the power of 2 times 10. And because of the power rule, a to the power of b times c is equal to a to the power of b bracket outside the power of c. So we could have break it up as bracket 5 squared to the power of the outside 10. The 5 squared inside, that will be our 25. Then the outside 10 is like this. This is our answer. Okay? Express root 8 as the power of 2. Let's break it down part by part. This square root, we know that it's a 1 over 2. The exponent, power 1 over 2. Equals to 8 to the power of 1 over 2. Okay? Then the 8, we know that, okay, it's 2 to the power of 1 is a 2, 2 to the power of 2 is a 4, 2 to the power of 3 is an 8. So we know that it's equivalent to 2 to the power of 3. 2 to the power of 3, that's what we replace. And then the outside 1 over 2. So if we say that clearly, this is the 8, this is the 8 as well. 2 to the power is also an 8. Then apply the power of the power rule, which is a to the power of b to the power of c equals to a to the power of b times c. Now our b and c, it's 3 and 1 over 2. So we will have 2 to the power of 3 times 1 over 2, which is 2 to the power of 3 over 2. Yes, we do have an expression like this, okay? Simplify that. Okay, so now you have to be very, very careful that this 2 over 3, it's only responsible for the h only, okay? It does not, this 2 over 3 does not apply to the 4, okay? This is a quick reminder for you, okay? So now, but what applies to the 4 is this outside number. You need to apply to the 4, you need to apply to the inside. So for the formula saying it's a times b to the power of c, you will have a to the power of c times b to the power of c. The c power has to be applied to both the a and the b. So you will have 4 to the power of 3 times h of 2 over 3. Of course, there's a power of the power, so we put a bracket for them and put a 3 outside. 4 to the power of 3, which is 4 times 4, which is 16. 16 times 4, which is 64. So which is 64 times, and then this one, it will be the power of the power, a to the power of b to the power of c. It's a to the power of b times c. So it will be h to the power of 2 over 3 times 3. The 3 and the bottom 3 can cancel out, so we will have 64h squared. Okay. This one's a little bit tricky because you see, well, there's nothing, numbers are available, right? So let's break down one by one. I copied down the answer first, and I will use different colors. So for the black part, we will have a times square root a divided by the cube root of a squared, okay? Then equals to a to the power of k. Now look at the black part first. A to the power of nothing, we see nothing there, but it still exists as an a, we will think it as a to the power of 1. Okay, this is the rule. Now, if something exceeds itself, that means it is something to the power of 1. Okay? The next thing is the square root of something, it's equals to the power of 1 over 2. Okay? So, and also, cube root of something, that means it's to the power of 1 over 3. So then for the black part, we could have written as a to the power of 1 times a to the power of 1 over 2. Okay? Then the blue part, we're going to have what? We're going to have a to the power of 2 to the power of 1 over 3. Now let me use red for the rest of them, for the steps. Okay? And then the pink part, it still remains as a to the power of k. Alright? Then we combine the top part first, because we have a of something times a of something, which is a to the power of b times a to the power of c is a to the power of b plus c. So we will have a to the power of 1 plus 1 over 3 divided by the bottom. We're gonna have what? We're gonna have the power to power, which is a to the power of b to the power of c, which is a to the power of b times c. So we will have a to the power of 2 times the 1 over 3. Then the pink part still remain as a to the power of k. Let's simplify on the top. This one, it's 1 plus 1 over 3, which is a to the power of 4 over 3, because 1 plus 1 over 3, which is 3 over 3 plus 1 over 3, which is 3 plus 1 over 3, which is 4 over 3. Okay? Then the bottom one, it's 2 times 1 over 3, which is a to the power of 2 over 3. And that equals to the right-hand side of a to the power of k. Nothing changed. So now here it's a to the power of something divided by a to the power of something. We have another rule, which is a to the power of b divided by a to the power of c equals to a to the power of b minus c. So then we're going to have a to the power of 4 over 3 minus the 2 over 3. And that will equals to our a to the power of k. By doing subtractions between the powers, we're going to have a to the power of 2 over 3 equals to a to the power of k. Because the bottom, a with the same base, the exponent will also be the same. Therefore, 2 over 3 equals to k. Okay, express 8 over 2 as a power of 2. So we are actually trying to modify a little bit. Again, so 8 to the power of 1 over 2, we have to change the 8, right? This 8, we know that it's 2 to the power of 3. This is something you have to memorize. 2 to the power of 3. Okay? Modify that, then apply the power of the power rule, which is a to the power of b times c. You're going to have 2 to the power of 3 times 1 over 2, which is 2 to the power of 3 over 2. And that will be a power of the 2. Express root 3 as a power of 9. Oh, this is a tricky one. Because we know that, okay, 3 square root, it's 3 to the power of 1 over 2, right? Because we know that something, square root, it's something to the power of 1 over 2. But the thing is, we have to express the 3 in terms of the 9 as well, right? So that means we need to think about how can we change a 3 into something related to the 9. We know that, okay, square root of 9 is a 3. So that means 9 to the power 1 over 2 is a 3. We could have used this information, which is a reverse process. So we're going to use this to replace this 3. So we're going to have bracketed, of course, 9 to the power 1 over 2. And then, of course, the original 1 over 2 outside. Then we have to apply the power of the power rule, which is a to the power of b to the power of c. It is a to the power of b times c. This is 9 to the power of half times half. So top times top, bottom times bottom, we're going to have 1 over 4. That's it. Okay. So now this one is a little bit difficult because we have 1 over. Remember, when we say about the reciprocal thing, it's 1 over something is equivalent to that something to the power of -1, right? So without further ado, we can quickly turn this one into the entire bottom of the 4 times root 2. Don't change that first. 4 root 2, but the entire thing to the power of -1, okay? Later on, we can try to multiply that, okay? So now this 4 is what? The 4 we know that it's a 2 squared, right? So we can then change that into a 2 squared, okay? Times the what? Times the root 2. Now let me highlight it first. This 4 is this 2 squared, okay? And this root 2 will be right at here. That will be 2 to the power of 1 over 2, right? Because we knew they are, we knew that it is square root of something equals to something to the power of 1 over 2, okay? Now, don't get confused. Hey, I've just multiplied the 2 and the top 2 together and the 1 over 2 together. That becomes 1. No, because you remember one thing, that it's a to the power of b times the a to the power of c. You see the times is at the bigger side. It's at the bottom, right? So you will write it as a to the power of b plus c. We're going to apply the rule here as well. So we have 2 to the power of 2 plus the 1 over 2. This multiply sign, it's this dot in the middle, okay? Because they are multiplying together. And now, of course, don't forget your -1 outside. 2 plus 1 over 2, you will have 2 to the power of 5 over 2. And then to the power of -1 outside, okay? So this is, again, it is the power of the power rule, which is a to the power of b to the power of c, which is a to the power of b times c. Obviously, this is the b, this is the c. You're going to multiply them together, which is 2 to the power of -5 over 2. Okay? That's it. Write down the value of 10 to the power of 0. So anything to the power of 0, it's a 1. So that will equals to a complete 1. Write down the value of 10 to the power of -2. Again, negative exponent, it's equals to 1 over that something, right? So this is a -2. We're going to change that as 1 over 10 squared, okay? You see there's no more negative. The negative turns into the fraction, okay? Which is 10 squared is 100, which is 1 over 100, okay? Or if you want to put that into decimal, it's going to be 0.01, okay? That's equivalent. Write down 8 as a power of 2. We know that it is 2 to the power of 3 because 2 to the power of 1 is a 2, 2 to the power of 2 is a 4, 2 to the power of 3 is an 8. Write 2 as the power of 8. Now, 2 as a power of 8, this is a little bit difficult because now we knew that, okay, 2 to the power of 3 is an 8, right? But then we don't want 2 to the power of 3. We want 2 only. That means we have to take the cube root on both sides, right? Because we take the cube root on both sides, then the cube root and the third power of the 2 will be gone. So you will have 2. And that will equals to the cube root of 8. So as we remember, the cube root of something, we're going to write it as something to the power of 1 over 3. So this one is, we're going to write it as 2 is equals to 8 to the power of 1 over 3. Okay? Write down 1 over 4 as a power of 2. So 1 over 4. We're going to multiply that. That is what? That is 1 over 2 squared, right? And because we remember 1 over something is equal to something to the power of negative 1. So we're going to have the 2 squared, the entire squared, to the power of negative 1. Then we apply the power of the power, a to the power of b times c, a to the power of b times c. That's equals to 2 to the power of negative 2. Okay, sorry. I make it clear. It's 2 times negative 1, which is 2 to the power of negative 2. Next. Now, this is a difficult fraction exponent because it is not 1 over 3. It's 2 over 3, right? So we can then break it down into 2 parts. This is something you have never seen it yet. So which is 2 over 3. You could have break it down as something to the power of 1 over 3 first, which is taking the cube root, then you squared it. It's the reverse process of the power of the power. Okay? So this, the first thing, of course, we're going to write as 27 over 3, 4, 3 to the power of 1 over 3 first. Then outside, we still have the to the power of 2. Okay? That's power to power. So now let's focus on the inside part first, which is taking the cube root. So we keep the big bracket outside, put a 2 there. Then we have the cube root of the 27 divided by the cube root of the 343. Okay? Again, because of the power has to be applied both the top and the bottom in the fraction. So again, keep the squared outside first. Let's solve what's inside. Cube root of 27, we know that 3 cube is 27. So 3 cube is a 27. So that means the cube root of 27 will be a 3. This is a 3. And then the cube root of 343 is a 7 as well. Okay? Because 7 cube is 343. So 7 is going to be the cube root of 343. So now, at last, you have the square applied to the top and the bottom. You will have 3 squared over 7 squared, which is 9 over 49. Move on. Oh, this one is 3 times 4 to the power of 2k plus 8. So this is obviously very difficult to solve. But there's a 3 outside and there's a 24. So we might as well just take the division of the 3 on both sides. So the 3 and 3 cancel out. You're going to have 4 to the power of 2k plus 8 equals to 24 divided by 3, which is an 8. So, hey, this is going to be 4 squared, right? Because 4 times 2 is an 8. No, because we are learning about the exponents. So we need to think about what is common for them. This is a 4, this is an 8. They are both the exponent of the 2's, right? Because 2 to the power of 1 is a 2. 2 to the power of 2 is a 4. 2 to the power of 3 is an 8. So we could have used these two. Okay? So let's just rewrite the 4. Let's say this 4, it will become what? That will become 2 squared, right? The power of 2k plus 8 outside has never changed. We just changed the 4 into 2 squared. Nothing else. On the right hand side, the 8, we can also modify that as 2 to the power of 3 because 8 itself is equivalent to 2 over 3. So now we sort of have a common base, but we still need to solve for one thing because here we have a thing called power of the power, which is a to the power of b to the power of c equals to a to the power of b times c. So we're going to multiply this 2 and the entire 2k plus 8. Do not just multiply the 2k only. So your answer on the left hand side should be 2 and then 2 times bracket 2k plus 8. They multiply as the entire block. Do not try to separate them or only multiplying the 2k. Right hand side equals to 2 to the power of 3. You do a little bit math on the blue part, which is 2 to the power of 4k plus 16 and equals to 2 to the power of 3. Because both of them now, it's only a pure exponent of the 2, right? The power of the 2s. So which is the 4k plus 16 is equivalent to the 3. We could have extracted that particular information right as 4k plus 16 equals to 3 without the bottom 2 anymore. So do the simple algebra, minus 16 minus 16. 4k equals to negative 13. K equals to negative 13 over 4. Okay, move on. Y equals to 16 times 10 to the power of 8k, where k is an integer. Find an expression in terms of k for y to the power of 5 over 4. Give your answer in standard form. Okay. Now this one's a little bit tricky, but we still can figure that out. Okay. So let's figure out the y first. Okay. The y we express that first is y equals to 16 times 10 to the power of 8k, right? We want to find 5 over 4 from here. That means we have to apply, basically, we're trying to apply the 5 over 4 power to the y, right? So let's just do that. How can we do that? We bracket it to the power of 5 over 4. And don't forget, because this is the black one, is the original y expression. So if we want to take the power of 5 over 4 to the y, we also take the same thing on the right hand side, which is here to the power of 5 over 4, right? Okay, so now the left hand side is going to be 5 over 4, which is the things that we are looking for. Then how about here? Now here you will have a times b to the power of c, which is we have to put the c on the a and on the b as well, because we have to distribute the power into the a and into the b. So we're going to have 16 to the power of 5 over 4 times 10 to the power of 8k, and then to the power of 5 over 4, because I add the bracket because you can't directly put the power onto it, right? So let's figure out this one first. 16 to the power of 5 over 4, which is, now, again, anything to the power of a fraction, 5 over 4, you can separate it, send anything to the power of 1 over 4 first, then taking the fifth power later. So, now, this is 16. 16 is it's the product of a bunch of 2's, right? So 2 to the power of 1 is a 2, 2 to the power of 1 is a 2, 2 to the power of 2 is a 4, 2 to the power of 3 is a 8, 2 to the power of 4 is a 16. So we're gonna rewrite this 16 as 2 to the power of 4 and then to the power of 5 over 4. Okay? And then the right hand side, obviously this is the power of the power, which is our 8k multiplied with the 5 over 4. And this is also power of the power, which is a to the power of b to the power of c equals to a to the power of b times c, which is 2 to the power of 4 times the 5 over 4, right? And then times 10 to the power of what? Now 8k times 5 divided by 4, you could have cancelled out the 4 and the 8, which is 2 and a 1, which is 2k times 5. You're going to have 10k at the top. And here, 4 times 5 over 4, you will cancel these two out. You will cancel these two out as 2 to the power of 5, which is 2 to the power of 5 times 10 to the power of 10k. Okay? So, yeah, our answer in standard form, which is like this. Or if you want to separate the 2 to the power of 5, we can continue the list, which is 2 to the power of 5, which is 16 times 2, that's 32. So our answer is 32 times 10 to the power of 10k. Okay? Last two questions. Okay. K times root a, where k is equal to a to the power of n. Find the value of n. Okay. So now we can then think of this one first, right? Now, we write it out. Root a to the power of 7 equals to k times the root a, right? But then it says k is equals to a to the power of n. So we can replace this k with the a to the power of n. That means everything is the same except the k turns into a to the power of n. Okay? So now let's recall from what we have learned. This one is the power of the power, right? The square root of something, it's something to the power of 1 over 2 first. So we're going to write it as a to the power of 1 over 2, then to the power of 7. Okay? And also the right hand side, the a to the power of n is something we have done already. This part is what? It's also times a to the power of 1 over 2. Okay? So far so good, because that's the only rule that we applied. Then the next thing is, on the left hand side, we have to use the power of the power. A to the power of b to the power of c. It's a to the power of b times c. So the left hand side, we're going to have a, now I'll write it at the bottom, a to the power of half times the 7, right? Because it's power of the power. Then on the right hand side, you will have what? You will have a to the power of b times a to the power of c, which is a to the power of b plus c at the top. So you have a to the power of n plus 1 over 2. So the left hand side is a to the power of 7 over 2, which is nothing special. Whereas on the right hand side, you can't simplify that because that one is an alphabet, n, and then the next term is a number. But since both of the expression now has the base of the a, that means the exponent is the same, which is 7 over 2 equals to n plus 1 over 2. So both sides minus the 1 over 2, 7 over 2 minus 1 over 2 will equal to n. It will be 6 over 2 equals to n will be a 3. Last. Okay, again, this one, 1 over something, it's something to the power of negative 1, right? So you will have 2 to the power of 2 times root 2 to the power of negative 1. Okay? And that's equals to what? Again, the root 2, we say root of something is equal to something to the power of 1 over 2. So you will have 2 times, because 2 root 2, not 2 plus root 2, is 2 times root 2. The space in the middle, it means they are multiplying, which is 2 to the power of 1 over 2. Okay, let me put it in blue, which is 1 over 2. Outside is the negative 1. And then the 2 to the power of nothing here, but it still exists as a 2, right? So that's default to be a 1 there. And again, a to the power of b times a to the power of c, it's equals to a to the power of b plus c, right? So we have 2 to the power of 1 plus the 1 over 2. Then we bracket the whole thing and apply the negative 1. So now let's focus on the adding here, which is 2 to the power of 1 plus half means 1.5, means 3 over 2. And then the outside, you still have the negative 1. At last, you will have the power of the power, which is a to the power of b times c. So you will have 2 to the power of 3 over 2 times the negative 1. Sometimes I bracket it to avoid confusion. So it's 2 to the power of negative 3 over 2. Okay, that's it.